Good afternoon, learners. Welcome to this wonderful physical sciences webinar today. I'm going to give the other attendees about 2 minutes so that everybody can log in. My name is Marita Kotze. I'm the Senior Education Specialist for Physical Sciences at Impact, part of the Optimi Group. So welcome. Physical Sciences, my passion, physics and chemistry. So thank you for listening this afternoon. Let us just give it another 2 minutes for the attendees to log into the system. Thank you. Okay. We're still going to wait a few seconds. So that everybody can attend. Okay. All right. If you will see there on your right hand side of the bottom, you will see there's a hand that you can use to show to me that you can hear me. So let us just see. Okay, let us start. I think everybody logged into the system. Okay, my name is Marita Kotze, Senior Education Specialist for Physical Sciences. Welcome to this session for Physics and Chemistry. Before we go on to this webinar, let's cover some of the basics. If you are struggling to hear me, make sure your audio is on and your speaker volume is turned up. You will automatically be muted when joining the session. Should you have any questions, you can ask your question in the question box below or on your right. Okay, I just want at this stage ask you to write questions in the question box below. I'm not going to deal with any questions during the session. I will do that afterwards. And during this session, I'm just going to cover all the content that I can. And please raise your questions in the question box, and I will answer your questions afterwards. Download this presentation and additional resources in the handout box below on your right. On that note, the additional resources that are loaded onto the system today are question papers from Doc Sainshaw. The question papers by courtesy of Doc Sainshaw. Please, you will see that it's only question papers. The memorandum we will load on the guided learning platform. So make sure to download the memorandums on the guided learning platform. If you're not registered with Impact, you can send me an email and we can see how we can help you with that. You will also find all this information in the question box below. Remember to send us your questions afterwards so that I can attend to your questions. All right. Okay, this is my favorite picture. Science gets you places. This is a photo taken on Antarctica, and the science gets you places are letters that's been cut out from blocks of ice. You can see that it is ice blocks. So yeah, if you are interested in physics and chemistry, this will be something that you can hold on to for your vision for the next years to come. Just so for you to say you can dream and you must dream, as long as it's part of physics and chemistry you can dream about. All right, you can dream about a lot of things. Welcome to this session. Okay, some general information for physics. It's very important to use a scientific calculator. Use your own calculator that works. Make sure that you do have the correct scientific calculator and mathematical skills for the relevant calculations that you need to do. That's very important for physics and chemistry, especially for physics. Okay, you received a formula sheet during the past test that you wrote, as well as the June exams and prelim and the end of year exams. You will receive, there are information sheets attached to your question papers and test papers. Please make sure that you know how to use your formula sheets that are attached to your tests and question papers. The previous or the recent test that you wrote, take the information sheets and write all the formulas that are not there. As you work for your physics and chemistry, you will see there are some of the formulas that's not on the formula sheet. Write the formulas that's not on it that you usually use as well, and make sure that you know how to use that and apply that as well. Attempt all calculations. A formula without an attempt to substitute will receive 0 marks. Units, units, units. I cannot state that enough times. Learners, you must use the correct formulas as from the formula sheet as well with units. And in case of vectors, there are direction. You have to state direction. No direction, no marks are awarded. So make sure that in the beginning you state the correct direction, what you choose for a positive and a negative direction. Remember, during when we mark it, there will be an option for both. There's not, if you choose to the right as positive, there will be an option on the memorandum for the positive option. If you state to the right as negative, there will be a negative option as well on the memorandum. So please make sure that you state in the beginning by using an arrow with a positive or a negative on top of the arrow, so that we know what direction you choose from the beginning. Okay, gravitational acceleration. The direction of gravitational acceleration downwards, it's 9.8 meters per second downwards, squared downwards. So if in projectile motion, you will see that by using the upward force as or upward acceleration, the upward direction is positive, your gravitational acceleration will the whole time be 9.8 meters per second squared downwards. Some important prefixes. Now, learners, I'm not sure if you know it, but if you do know, learn that in any case. Again, if you don't know, it's very important to know the prefixes for pico, nano, micro, milli, centi, kilo, mega, giga, and tera. If it's pico, it's a P, it stands for 10 to the minus 12. N, it stands for 10 to the minus 9. Micro, it's 10 to the minus 6. N, milli, it's 10 to the minus 3. C is centi, 10 to the minus 2. K is kilo, 10 to the third. Mega, capital letter M, 10 to the 6. Giga is capital letter G, 10 to the 9. And T. Remember, when these abbreviations is used, you need to multiply the quantity by 10 to the minus 12 or 10 to the minus 9. Please make sure that you know how to apply that. Okay. We are going to cover two topics in mechanics knowledge area. It's momentum and impulse, projectile motion. Momentum and impulse. If you look at the formulas, you will see that it almost look familiar, but you're not sure where this formula, they derive this formula from. Impulse, you can see it's Newton's second law. F equals ma, where acceleration is delta v divided by delta t. So if you derived it from the Newton's second law, you will see F net delta t equals m delta v is where the delta stands for change. So the moment you see the triangle, you will know that this stands for change. So change in time, change in velocity. So impulse is therefore the product of the net force and the contact time, and that is equal to a change in momentum. And a change in momentum is m change in velocity. Momentum, you can see here, is mass multiplied by velocity. So when we have change in momentum, it's change in velocity. What are we going to cover in momentum and impulse? We're going to look at momentum and impulse according to Newton's second law, change in momentum, conservation of momentum, and conservation of momentum in collisions. Okay, the first one, momentum and impulse according to Newton's second law. Now, what is Newton's second law according to momentum? Newton's second law is F net equals m multiplied by acceleration, mass multiplied by acceleration. That is Newton's second law. So now, in terms of momentum, the net force acting on an object is equal to the rate of change of momentum. So now here we will see change of momentum. That's where we combine the two of them. So therefore, we can state that's where impulse is coming into this equation, where we have a change of momentum, and the change of the momentum equals m change in velocity. Okay, for example, a tennis ball with a mass of 100 grams is hit and moves towards a wall with a velocity of 3 meters per second. So you can see here on the right-hand side the calculation. You can see the tennis ball moving towards a wall and hit the wall with a velocity of 3 meters per second square per second, and it returns from the wall 2 meters per second in the opposite direction. Can you see I indicate the direction? The movement to the wall is positive and the movement from the wall is negative. So now I can state that in my calculation, I can state that the final velocity is minus 2. The initial velocity is plus 3. So learners, please remember to choose your direction from the beginning in order to remember to do the calculations correct. So now you have what is given and what is asked. So what do we ask here? We ask you to calculate the force that the ball experienced. So in my formula, F net delta T equals delta P, I'm gonna calculate my F, the force. All right. So how do I know I need to use this formula? Because there's a contact time. The contact time with the wall is 0,03 seconds. 0,03 seconds. So now you know, through the fact that there's a contact time, you know we're working with impulse here. You have to consider the time, the wall, the contact time that the tennis ball do have with the wall. Okay, so now we can first, you can either do it as one calculation by just using this formula, or you can first calculate the change in momentum. The change in momentum is the final momentum minus the initial momentum, and that is the final momentum is calculated by the mass multiplied by the final velocity minus the mass multiplied by the initial velocity. So here you can see now you use the direction of the final velocity is -2. Okay, so therefore the momentum do have a negative direction. So that's why you have to state momentum of 0.5 kilogram per meters per second to the left, because to the left is negative. You don't leave the answer as negative. You need to state that the momentum is positive 0.5 kilograms meters per second to the left. So if you calculate, therefore, then the force, you will use the minus 0.5 so that you can see that your answer is again minus 166.67, and therefore it will be to the left. Your answer is therefore force is positive 1.66.67 Newton to the left. Changing momentum is a vector and therefore has direction. That is indicated by the sign in the answer. So please, learners, make sure that you can apply the negative signs and how to do that. Please, if you do have any difficulties regarding that, make sure that you work through a lot of questions to become familiar with that. So now, what is the relationship of momentum and impulse? As you can see on the previous page, momentum and impulse, you can see the time taken. What is the impact of the time? We want to know what is the impact of the time. Here you can see if you have an increase in time, so the time taken to go through the hay, here, there's a time. Can you see there's an increase in time? So the impact of the force will be less. Why? Because if we look at the formula here, if we want F net on the left-hand side, can you see, is inversely proportional to the change in time. So it's inversely proportional to the change in time. So what is happening here? So the change in time, if the time is bigger, the force will be less. So if the time is less, the force will be bigger. The impact of the force will be bigger. So momentum, here can you see in both cases, will be same, but the force will increase, the time will decrease, the force will decrease when the time increase. Make sure that you can explain this relationship between momentum and impulse in your explanations. Now, the conservation of momentum. What does conservation mean? It means that there must be some things certain things that must be part of it for the momentum to stay constant. So it must be total linear momentum, must be an isolated system. If it's an isolated system, then we can say that momentum remains constant in magnitude and direction. So we do note that the vector sum of the momentum of all parts in an isolated system before a collision or an explosion is equal to it afterwards. That's why we do have momentum before equals momentum afterwards in conservation. Now you can ask me, okay, if it's the collision that we do have, When will it be an elastic or an inelastic illusion? I will explain that just now. So, momentum before equals momentum after. Make sure that you do know for your momentum before you add A and B together, it's the initial velocity that you use. And afterwards, after the collision, it's the final velocity that you use. Okay, so if in this instance here, you can see it's a bullet that hits a block, and the block with the bullet moves, block with the bullet moves afterwards and fell to the ground. Here you can see the bullet and block are together. So then in your formula, you use the mass of the bullet and the mass of the block. You add the two together, and the velocity will be of the block with the bullet inside of it, the final velocity. Okay, in this scenario, we do have the velocity of the final velocity of the block and the bullet the moment it hits the block. Okay, so we ask here what velocity. After impact, the bullet embeds into the block and the block leaves the table with a velocity of 1,22 meters per second, which then falls to the floor. It hits the floor with a velocity of 5 meters per second. So what do we want here? We want to know the magnitude of the velocity with which the bullet hits the wooden block. We know the velocity of the block and the bullet together. Right, when it starts leaving the table, but we want to know the magnitude of the velocity with which the bullet hits the wooden block. So which one? We want the initial velocity of A. A is the bullet. So make sure that you do understand which one is which one in order to do your calculation correct. Okay, you will either have a mark for that or that. For me, it is easier to write it from the beginning as P total before equals P total after, and then from that derive what you do have in the beginning, and there's the explosion and what you do have after the explosion. In order to do that, you need to write the momentum of A, the velocity of A, the momentum of B, the velocity of B. All right, so make sure how to derive the correct formula. So here I do have an explanation for conservation of momentum in collisions. All right, we do have here two objects. Okay, in elastic collisions, objects come apart after the collision, therefore momentum and kinetic energy are conserved. Can you see you do have two objects and they collide with each other and afterwards they moving again. All right. So the kinetic energy is conserved. And what is happening on this side? On this side, the two objects connect with each other and move together afterwards. After the collision, they move together. So what is happening here? Kinetic energy is not the same. So momentum is conserved, but not the kinetic energy. So there will be a kinetic energy transfer into heat or whatever, but it will not be the same again afterwards. So therefore, it is an inelastic collision. Remember that you must be able to explain things like this. That is level 4 questions. So now, what is a projectile motion? We have a base jumper here that's jumping from a cliff. Can you see there? There goes the base jumper. Now, learners, that is a projectile. That is a projectile motion. You can see that the acceleration that takes part here is the acceleration downwards. It is 9.8 meters per second squared downwards. It's the only acceleration that we do have here. Okay, so now what is a projectile? It's an object that is projected and launched into the air. Can you see it's jumping off the cliff? That is a projectile. It's shooting, kicking, hitting, or throwing. If somebody jumps, it's throwing himself from the cliff. Whatever reason, or somebody pushes you from the cliff, then you will kick and hit. All right, so after that, it moves only under the influence of gravitational force. So make sure that you do understand what is a projectile, and a projectile is only gravitational acceleration. Okay, so the gravitational acceleration is the weight or gravitation force, and it will be 9.8 meters per second squared downwards. All right, so if you choose upward direction as positive, the gravitational acceleration will be up and down. If, for example, you throw a ball up into the air, you will see that the gravitational acceleration will be 9.8 meters per second squared downwards always. If you choose up as positive, it will therefore be minus 9.8 meters per second squared up as well as down. So what is terminal velocity? Now, pupils, terminal velocity is when acceleration is 0 meters per second squared. So the constant terminal velocity, we say when the upward forces due to air friction are equal to the downward force of the object's weight. So your upward forces, both of them will be equal to, the upward force will be equal to Fg, then gravitational force, or if you have a gravitational force. So equation of motion, we're using in projectile motion, we use your equations of motion. Make sure that you know how to apply these equations. So what are you expected to do in this section? You have to apply equations of motion to vertical motion. You have to explain and use graphs of motion. If you do have any difficulties with graphs, please go to your grade 8 and 10 work. If you don't have your notes from grade 10 and 11, grade 10 and 11 work, go to your grade 10 and 11 work and download the science clinics notes. I do have some information about science clinics later on, where you can download the grade 10 and 11 notes as well. Make sure that you go through all your grade 10 and 11 graph work and know how to apply it and how to explain vertical motion. Explain why some objects reach terminal velocity. So, a few tips to help you use the equations for motion for projectile motion. Choose a direction. I cannot state this too much, because if you don't have a direction, you will lose marks. Learners seldom ask me, ma'am, but I know my work and I apply it and I do my calculations, but I don't get the marks. Why? Because some stupid faults that you use by not using direction or showing direction or state direction in the beginning. It's normal things that learners do wrong. So make sure that you can state the direction. Decide on the time of interval that is relevant to the question. Write down and know the values for the initial velocity, final velocity, gravitational acceleration, the vertical component, the vertical displacement, and the time. If an object is released or dropped by a person that is moving up or down at a certain velocity, the initial velocity of the object equals the velocity of that person. So, for example, if you throw a ball up into the air at a velocity of 3 meters per second, that is the initial velocity. The place where if I take a pen and I say, okay, you know what, the ball, this is the movement of the ball. I throw it up into the air 3 meters per second squared. My final velocity there will be 0 meters per second. My initial velocity is 3 meters per second. Final velocity will be 0. The moment the ball turns, at that point, it will start with the initial velocity of 0 meters per second. And at that point here, it will be 3 meters per second downwards again. So at that specific point. So make sure that you do realize and know what the initial velocities are. And for the upward movement and the downward movement, so for example, if it's 3 seconds upwards and 3 seconds downwards, it will be the same. The time for that specific displacement, the time will be the same for up and down, as well as your velocity, as well as your displacement. Make sure that you do understand that. So, what type of questions you need to explain? Yeah, you need to explain the difference. As you can see here, it's free falling. There it is. There are upward and downward forces. This is not free fall. It's because there are an upward force that decreasing. That's the descending of the jumper. Okay, so make sure that you can explain the different accelerations. Okay, now I do include a example here for you to see the different. It's just an example of a bullet that's fired vertically upwards and ignore the effect of air resistance and calculate the maximum height reached. As I state, write down what you do have. Now, learners, can you see you have initial velocity, you have gravity, you have final velocity, and you need to calculate the maximum height. Now, I often hear learners send me an email and ask me and say, you know what, ma'am, there was not enough information. Okay. How do you explain that? You know what? The bullet is fired vertically upwards at 2 meters per second. Okay, that's the only thing that I do have here. So yeah, my initial velocity is 2 meters per second. Ignore the effect of air resistance. You need 3 variables here in order to use your formula. Okay, ma'am, but you gave me only 1. What other variables are there? G. Yes, G. Because the ball, you throw the ball upwards, there's only G, it's a gravitational acceleration on the ball downwards. Okay, ma'am. Right, the maximum height. Maximum height, there's your clue. My final velocity is 0. Can you calculate the displacement now? Can you calculate the height now? Yes, because I do have 3 and I need 3 in order to do the calculation. Now here at B, I give something else. I say, okay, you know what? At what height it will be moving at 100 meters per second. Now my final velocity will be 100 meters per second and not 0 meters per second. Can you see why it is important to write down what are given here? Because the moment you start doing this, then it becomes easier to do the calculation. Remember, in your calculation, when you substitute, you need to write the negative sign. So that's why it's necessary to write negative 9,8 there in order to understand and use it here again. So for that, we will see in any case that that is if we take it to the other side, it will become positive, and therefore your vertical component will be positive. Okay, enough of that. All right, now we start with the other knowledge area that you did in term one. It was matter and materials, and the part that you did, what that was the most important part, is organic chemistry. Okay, organic chemistry. There are 5 topics that I'm going to cover here: organic molecules naming, functional groups, intermolecular forces, and organic reactions. So let us start with the organic molecules. All right. What is a hydrocarbon? As you all know already from your grade 10 and 11 years, that carbon is in group 4 on the periodic table and therefore do have 3 valence electrons in its outer energy level. So by having 3 valence electrons, there are 4 valence electrons. 4 valence electrons do have therefore placed 4 electrons where they can share. Okay, so carbon atoms form long chains by sharing electrons, covalent bonds. You need to know what a covalent bond is in order to do organic chemistry, because it's all about covalent bonds here. Hydrogen share with carbon. Hydrogen share with carbon. Hydrogen, the single electron in the outer shell of the hydrogen shared with carbon. Can you see this is the Lewis diagram that I used here to show you the covalent bonds between carbon and hydrogen, carbon and hydrogen, carbon and hydrogen, and then carbon share 1 electron with another carbon. And that I show the single bonds here. This is the Cooper notation. I use the Cooper notation to do the organic molecule structures. To use the Cooper notation. Okay, we do have single bonds, double bonds, as well as triple bonds. Now, how do double bonds form? Where 2 carbon, these 2 of the 1 carbon share with another carbon 2 electrons, and there you form 2 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 2 bonds between the carbons. Here, the 2 carbons share each 3 electrons. So it's 1, 2, 3, 4. 1, 2, 3, 4. It's again 4. So this carbon, there are 4 covalent bonds and 4 covalent bonds. So the formula types that we use in organic molecules are molecular formulas, condensed structural formulas, and structural formulas. Now, where we use the Cooper notation, it is a structural formula. Can you see it looks like a structure? So a molecular formula is where I write this one. There's 2 carbons, and there are 2 carbons. It's not this one, because this one only has 4 hydrogens. So no, it cannot be this. So it can be, for this, it can be C2H4. For this, it will be C3, no, C2H2. So the molecular formula for the triple bond will be C2H2, C2H4, and C2H6. So the molecular formula that we do have here is the molecular formula for ethane that we see here and here. Okay, the condensed structural formula For the same one will be CH3. Can you see CH3 and CH3? So it is again ethane. So let us go on to the organic functional groups. We have different functional groups in organic chemistry: alkanes, alkenes, alkynes. So the single bonds, alkanes, double bonds, alkenes, and triple bonds, alkynes. The moment I do have an haloalkane or a haloalkane that bonds to a alkane, we say it's a haloalkane. If it's a halogen attached to a alkane, it is a haloalkane. There you can see we have the same ethane with a bromine, so it's bromoethane. Here we have a hydroxide group. Can you see the hydroxide? It's OH sharing with the carbon. So again, we have ethanol. Example, ethanol. The condensed. This is the molecular formula. Can you see all of them are molecular formulas? So the condensed formulas will look something else. So this will be CH3, CH3 for the condensed. Okay, so let us just look then at aldehydes. Aldehydes is where there's a double bond oxygen connected to the carbon. So there you can see 1, 2, 3, 4, and 1, 2, 3, 4, 1, 2, 3, 4. So again, each and every time there's 4 bonds around the carbon atom. And in this case here, we have a double bond oxygen and a hydroxide group, and that is the carboxylic acid group, and the name is ethanoic acid. All right, now organic molecules naming. In order to know what hydrocarbon we do have, we indicate it with a root name. Now the root name depends on the number of carbons that we do have. Meth, F, prop, with pent, hex, hept, opt. Okay, for 2 carbons, it's F. For 3, it's prop. 6 is hex. 8 is opt. Okay, so now we look at the homologous series. The homologous series, as I